So now let's look at the haptic loop. And what this is the series of steps that you need to take in order to create a haptic rendering and control the haptic device to feel the way you want it to feel for the user. So this way this starts out is the user is grasping onto the endpoint or the haptic interaction point of the haptic device. The device shown here is a little bit more complicated than the hap kit that you're using in this class, but nonetheless all the steps are the same. So in the beginning, the user is holding on to this endpoint and moving the haptic device around. And if we're not trying to render anything, the user should actually feel just like they're moving around a stylus in free space, because ideally the mechanical properties of the haptic device are so minimal that the user won't feel as if he or she is interacting with a small robot. So to begin, the user moves around the haptic device. The movement of the device is sensed, and this is this first step over here. And there will be joint sensors on the device which will record that movement. Now, those joint sensors, if you have a high degree of freedom haptic device, there may be many of them, but on your hap kit there's only one, and this is the Magneto-Resistive Sensor, which is on the actuator of your hap kit. So this records the motion of that joint, and then the forward kinematic equations are used to determine what is the motion of the haptic interaction point. The place where the user is actually holding onto the haptic device, we don't actually have a direct measurement of that position. What we have is the measurement of the joints on the device. And so you need to use your kinematic equations that we discussed in an earlier lecture to figure out how is the actual haptic interaction point moving based on those sensed joint angles. And this is something that you would have to program into your haptic loop. In the third step, you would need to figure out whether you're contacting objects in the virtual environment. Now this is much more interesting and complicated if you have a high degree of freedom haptic device, like in this example, maybe there's a virtual object like a box and you're controlling this stick in space. And so you would need to figure out, have you even hit an object or not? Because that tells you if you need to even do any haptic rendering at all. In our case with the haptic device, there might, for example, be a very simple virtual environment, like a virtual wall. And our question is, if that's our representation of the haptic interaction point, are we outside the wall here, or have we actually entered inside the wall? And so it's that contact detection that's the third step. The fourth and fifth step finish the rendering steps, which are all included here in this block. It may be that if you have a complicated virtual environment that you might need to figure out, well, if the user's actually moved inside the surface of the virtual object, maybe we need to figure out what is the relevant surface point to be rendered. This is not a big deal for a 1 degree of freedom haptic device. So for the most part, you could ignore this for programming your hap kit, but it's good to be aware of it in case you do higher degree of freedom haptic devices later. The fifth step is probably the most important one, and that's just calculating the force, coming up with some equation to figure out what force should be displayed to the user based on this interaction with the virtual environment. And this is where physics comes in, whether it's real-world physics that you've programmed in order to try and make a realistic virtual environment, or maybe it's imaginary physics, equations that you've made up that try to describe this virtual world that doesn't really exist in the real world. So anyways, that's step 5. Step 6 is another kinematic step, but it's a kinematic step not about motions, but trying to translate forces to torques of the actuator. Because the force that you compute is being computed in this virtual world. So typically that will be a force in a Cartesian space, that is in a translation. But what we actually have on our hap kit to generate forces is a motor, which is actually torque. And so, as described in a different lecture, you can compute the torque from the kinematics based on the force that you've computed from rendering. And then the final step is to actually use an amplifier. Now this is not programmed, this is a physical device that's in the control system of your hap kit. It's on the little hap kit board, which is used to actually send the current to the actuator. So if you have a certain desired torque, the amplifier will then output a desired current to the haptic device, and then the haptic device's actuator will be caused to rotate or to apply a torque, and then the user will feel that. So in the end, the user feels a force from the haptic device. Now, this loop goes around over and over again, and it's not happening slowly, it's actually happening quite fast. The rule of thumb for really high quality haptic devices is that this loop happens at about 500 hertz to 1 kilohertz in terms of how often it's repeated. On your HapKit, we just let our HapKit board try to run that process as quickly as possible. We don't set it to occur necessarily at a specific rate, although you can program it to do so. So one of the things that you might do if you are having trouble with programming your device or getting your virtual environments to feel realistic is to check whether you're able to actually compute this loop at the rate that you need. If you have a very complicated virtual environment or you're doing other things in the loop like recording data, that might slow down your ability to get through this loop quickly, and then your virtual environments won't feel as good. So that's just a tip for future debugging. So the fun part of actually programming or rendering haptic virtual environments is figuring out how you want to calculate the force. Basically, you are going to come up with a function and you're going to program it in order to create a compelling haptic virtual environment. And just to remind you, this force-motion relationship, it could be realistic. It could be based on real physics, or it could be unrealistic. It could be some new experience that you want to provide the user that doesn't exist in the real world. It could be fun. It could have to do with a game, a haptic game that you want someone to play, or it could be educational. It can try to teach someone about some physics in the real world. Usually you would like these forces to be somewhat expected, and that the most compelling haptic virtual environments are ones where the user is getting a response that feels like what they would expect to get from interacting with this virtual environment. But every now and then, especially for games or fun haptic virtual environments, you might want to actually render something unexpected. Just note that as opposed to just displaying unexpected visual things, displaying unexpected haptic things might make your user be a little bit uncomfortable.